Good morning, students. Today we are going to learn about types of sets. Sets makal ma'am tamasika. Number 1, empty set or null set or void set. A set having no element is called the empty set or null set or the void set. It is denoted by phi or second bracket having no elements. Second bracket ini natraga phi habasina denote tawgani empty set. Empty set haidi kaino set amadi element amta laitaba. A set with no elements is called empty set. Example set A. X belongs to natural number and x lies in between 1 and 2. X से 1 गा 2 गा मरक्ता लेवे any natural number अमा हाइबको 1 गा 2 गा मरक्ता natural number अमता लेतेब natural number अमता लेतबनिना the given set A is a empty set is an empty set which is denoted by phi Roman number 2a. X is the real number and x square is less than 0. X square is less than 0 means the square of real number is negative 5. Any real number amada squaring tawbase positive tava natraga 0 tane, it cannot be equal to negative. So the given set A is equal to 5. 5 means a set having no elements. Element amta laitaba set singse kai korani 5 set empty set or null set or void set kauneba. Number 2, singleton set. A set having only one element is called singleton set. Set amada element ama katang laytaragadi aduguma set to singleton set koreko. Let us consider some examples. Examples A. Set A, x belongs to natural number n and x is less than 2. X set 2 dagi hantaba natural number have 2 dagi hantaba natural number di kayore 1 oreko. 1 is the only natural number which is less than 2. So this set consists of only single element 1 and set A is called singleton set. Number B. Set B, x belongs to z and x square is equal to 0. X element am yaar x se integer amane ko x square की value से क्या तावा 0 तावा. X square की value na 0 तावा di 0 नेवा. Since 0 square is equal to 0, so set B consists of single element 0 and so set B is called singleton set. Next, number 3, finite set. A set is called a finite set if it has finite number of elements or its elements are countable. Nangi set amada elements sing se countable or natraga nangi elements sing sigi nangi set sigi elements sing se masing thiba ngam taragadi that set is called finite set. Finite set haitaragadi elements are countable. A set is called finite set if elements are countable. Example, set A consists of element x. X is natural number and x is less than 10. X and natural number amani x se kaidagi hantare 10 dagi hantaba natural number neba. Then set A consists of all the natural numbers which are less than 10. They are 1, 2, 3, 4, 5, 6, 7, 8 and 9. These elements are countable and so set A is called finite set. Number 4 type, infinite set. A set is called an infinite set if its elements are uncountable or it has infinite number of elements. When elements are uncountable, masing thiba ngamdabo oragadi, that set is called infinite set. Examples of infinite sets are set A, x belongs to z and x is less than 10. 10 dagi hantaba integers haitaragadi, there are infinite number of integers which are less than 10. And the positive integers are 9, 8, 7, 6, 5, 4, 3, 2 and negative integers the infinite case the -1, -2, -3, -4 and -5. So this set A is an example of infinite set. Then number B. X is an even natural numbers. The elements of these sets are 2, 4, 6, 8, 10, 12, 14 and 16. Any number EBR Sigi set se these elements are uncountable. And so set B is an example of infinite set. And some sets are this capital letter N. Capital letter N represents set of natural numbers. W, set of whole numbers. Z, set of integers. Q, set of rational number. Q dash, set of irrational number, and capital R represents set of real number. These are examples of infinite set and their elements are uncountable. Sigi elements sing se khona masing thiba ngamdaba ngakta oiniba. Duna sigi set sing se kaigi manung da sala infinite set ni ko. Natural number, whole numbers, integer, rational number, irrational number, and real numbers are examples of infinite set. Last type, equal sets. Two sets A and B are said to be equal if they have exactly the same elements, and we write A is equal to B. Nangonda set ani pireko. There are two given sets, set A and the set B. These two sets are said to be equal if they have exactly the same elements. Element ani se chap manaragadi akhoi set ani se equal set oini. If the two sets are equal, then we write A is equal to B. Sumai ineba. Example, set A consists of three elements. They are 1, 2, 3, and the set B consists of three elements. They are 3, 2, 1. Then check the elements of set A and the elements of set B. And set A and the set B elements in set check tauto. Elements manareko. Set A elements are written in ascending order, but in set B elements are written in descending order, and the elements are identical. Elements in set manebako. Therefore, set A and the set B are equal set. Then we write A is equal to B. Smaiter ito neba. Then set C have lower siko. Let us consider another set C whose elements are 2, 3, and 4. First, compare this set C with the set A. 2, 2, 3, 3. But 4 is not equal to this one. 4 ga 1 ga di manadabanina, we write A not equal to C. And so that set B is not equal to set C. Set A ga C ga manadabanina, B ga C ga sumana roiba. A ga C ga manada taradi, we write A is not equal to C and the B is not equal to C. Manadragana manade han itare, manaragana manay han itare ko. These are some types of sets. Set karagi makal ngatani. Number 1 the finite number 1 empty set lereko. Number 2 singleton set. Number 3 finite set. Number 4 infinite set. Last the kay legre equal sets. Then let's come to exercise 1.2. Exercise tula asiko. Exercise 1.2. Which of the following are examples of the null set? The P sings a finite set over color, null set over second crumble over no cantareko. Exercise 1.2, question number 1. Number 1, the set of odd natural numbers divisible by 2. The set of odd natural numbers divisible by 2. Set of odd natural numbers are 1, 3, 5, 7, and dot dot. There are infinite number of odd natural numbers, but all the odd natural numbers are not divisible by 2. 2 na amata na divide to roiba. And so the given set is an empty set, and it is denoted by phi number 2. Next for Roman number 2, set of even prime numbers. Even prime number, set of even prime numbers sida kana element yawi in thi doini ko. Ahanbada prime numbers sing se kana no. Prime numbers are 2, 3, 5, 7, 11, and there are infinite number of prime numbers ni ko. Among these prime numbers, 2 is only even prime number. 2 sa even soiba prime number soiba number neba. And so the given set consists of single element 2, and hence it is not a null empty set. Mas null empty set oidre ko. Roman number 3x. X belongs to n. X belongs to n means x is a natural number, and x is less than 5, and also x is greater than 7. Find any natural number which is less than 5. 5 tagi su hanthaba, but it should be greater than 7 tagi. 5 tagi hanthagadaba, 7 tagi chawgadaba. Sigumba natural number layroiba. Property animak se satisfy toba natural number layro. The given set is null set. Phi tareko. Roman number 4, y. Y is a point common to any two parallel lines. Y is a common point. Y is a point common to any two parallel lines. Now on the parallel over line aniyo. First draw any two parallel lines. If the two lines are parallel, nangi line anisa parallel oitaragadi moise kaknararoibako. If the two lines are parallel, then there is no common point in between L1 and the L2. So Y is a common point common to any two parallel lines. There is no point common to any two parallel lines, and this set consists of no elements. Sigi set sa point amta yauraroi, which is denoted by phi. Phi na denote orani ko. Phi na denote means nangi piramiba set sida element amta lairaroi have empty set ko. Next question number 2. Question number 2. Which of the following sets are finite or infinite? The period sets se finite oibana karambano, infinite oibana karambano kalase. Roman number 1. The set of months of a year. The set of months of a year haita sahi amada yawba tha mayam gi collection haiduni ko. It is finite set ore maramdi kaigino there are 12 months in a year. Sahi amada tha kya lay 12 lay duni ko. Since the set has 12 elements kya lay rani 12 lay rani. Elements sing se countable loitardi set 1 is finite set. Number 2, the set 1, 2, 3 ... This is the set of natural numbers. Since set of natural number is infinite set, elements are countable. Number 3, the given elements are 1, 2, 3, 99 and last element is 100. If the last element of a set is given, then that set is finite set. Last element pupiramagadi kai kaurani finite set kaurani since the elements are countable. Elements are countable or next Roman number 4. The set of positive integers greater than 100. The set of positive integers greater than 100. Positive integers mayamama kanadai chawba hengadaba 100 tagi ko. It is an infinite set since the elements of the sets are 101, 102, 103, 104, 105. Then we cannot write all the positive integers which is greater than kanadagi chawba henba 100 tagi chawba henba mayamam leiraniba. All the elements are uncountable. Masing thiba ngamdre ko. Masing thiba ngamdabanina sigi set sa kaida singrani infinite set to singani. Then Roman number 5. The set of prime numbers less than 99. The set of prime numbers less than 99 elements of this set are 2, 3, 5, 7 and last element is 97. Haibadi nangi prime numbers ngataneba kanadagi less oiba 99 dagi less oiba itardi 2, 3, 5, 7 and last element is 97 tareko. Itaradi sigi elements sing set countable or the given set is countable and it is called finite set kaurani. And let's come to question number 3. Question number 3. State whether each of the following set is finite or infinite. The piribu set sing se finite oibra infinite oibra yung se ko. Question number 3. Roman number 1. The set of lines which are parallel to x-axis. The set of lines which are parallel to x-axis. In Cartesian plane, there are two lines, horizontal lines and vertical lines. This horizontal lines is called x-axis and the vertical lines is called y-axis. And the given set is the set of the lines which are parallel to x-axis. There are infinite number of lines which are parallel to x-axis, or we can draw any parallel lines. Any lines which is parallel to x-axis. X-axis is the parallel or line mayam yek payani infinite case the yek payarani ko. And so the given set is infinite set. Number 2, the set of letters in the English alphabet. The set of letters in the English alphabet. English alphabet letters kya lay? Letters 26 lay ko. There are 26 letters in the English alphabet. The given set is finite set. Number 3, the set of numbers which are multiple of 5. The elements of the set will be 5, 10, 15, 20. These are multiples of 5 and we cannot write all the elements which are multiple of 5. 5 ki multiple mayam leirani adu loi ibadi ngamaroiba, and elements are uncountable do ore ko. And so the given set is infinite set. Then Roman number 4, the set of animals living on the earth. The set of animals living on the earth. We assume that all the elements are countable. Element element countable or in a collab. Living animals living on the earth habasida koigi animal mamsa koina masing thibanga main lowebuko. Aduga sigi set sa kaida singhale. It is finite set and lowe. Roman number 5. The set of circles passing through the origin. Origin power yekpa says circle mayam gi set haibako. Cartesian plane the x-axis haibam y-axis haibam lay. These two lines intersect at a point O. O is called origin ko. Origin oireba. Sigi origin se power ga yekpa circles mayam gi set haiba. Aina makal mayam yekpa yai ko. We can draw infinite number of circles passing through this origin, and so the given set is infinite set. Sigi origin se pharaga koina circle mayam am yekpa yagani. Dugi circle mayam dugi set hairaga di kai de singrani infinite te chingi ko. Then question number 5. Question number 5. Are the following pairs of the set equals? Give reasons. The piriba set singsa equal oibra hange ko maram piyo hai. Question number 5. Set A. Set A has two elements. They are 2 and 3. Set B. X is a solution of quadratic equation x square plus 5x plus 6 is equal to 0. A sina element ani yare 2 ga 3 ga ko. Set B sina x ama yare. X is a solution of quadratic equation x square plus 5x plus 6 is equal to 0 haiba quadratic equation si oidoine. Dudi sta lagtu se kai ga manarane. Koina first kai gi solution puthokani. Find the solution of the quadratic equation x square plus 5x plus 6 is equal to 0. We can solve quadratic equation by splitting method. Splitting method na solve tawrasiko. Then kay splitting method na solve tawge haitardi. First we have to find two numbers whose product is, here coefficient of x square is 1 and the constant is equal to 6. 6 into 1 is equal to 6 and their sum will be equal to 5. Number ani thiro, number ani ke product is 6 taba. Plus tawragana 5 taba ko. Therefore the two numbers are 3x and the 2x. This 5x can be written as 3x plus 2x for the first two terms. Taking x common from these two terms, we get x plus 3. Then for the last two terms, taking plus 2 common from this term and this term, we get 2x plus 3 equals to 0. X plus 3 common or x plus 3 is common to first term and the second term. Common log to x plus 3, we get x, we get this 2 is equal to 0. And the product of two factors is equal to 0, which implies that either x is equal to minus 3 or x is equal to minus 2. These are the solutions of the quadratic equation x square plus 5x plus 6 is equal to 0. So the elements of the set B are minus 2 and the minus 3, and elements of set A are 2 and 3. Manabra check toro. Check the elements of set A and the set B. They are not equal and hence matrix set A is not equal to set B. Habiti set A sa kay gamanadre, set B habisi gamanadre ko. Roman number 2. A. X is a letter in the word follow, and B. Y is a letter in the word wolf. Ahanbagi X follow habisi yaubaniba. They write A or write set A in the roster form. Roster form means write all the elements of set A. X represent X is a letter in the word follow. Irasiko F, O, L. L is repeated 2 times, so we have to write L is only once, then W. These are the elements of set A, then B. Y is a letter in the word wolf. Write all the elements of the set B. Elements of the set B are W, O, L, and the F. And check the elements of set A and elements of set B. Check the W, W, O, L, L, F, F. They are equal elements. Therefore, set A is equal to set B. Roman number 2 gidi equal sets tie aduga Roman number 5 ki CD equal Roman number question number 5 ki Roman number 1 CD equal sets tadre ko. Next topic is subsets. Next topic is subsets. Subsets sa kaino has a defined tarasiko. A set A is said to be a subset of another set B if every element of set A is also an element of set B, and we write A subset of B. This symbol represents subset. A set A is said to be a subset of another set B if every element of set A is in set B. A gi element yamse kanada lo yauraba B da lo yaw taragadi akoina A se kai kawi. A is called subset of B and the B is called si superset kaudoine ko. B is called superset of A. Example hanayang si gyantanaba. Let us consider any two sets, set A and the set B, whose elements are 1, 2. Elements of set B are 1, 2, 3, 4. Element ani si sek daw si ko. all the elements of set A are in set B, and B is the bigger set. B sina achauba set ni, A sina apikpa set neba. Aduga A gi element mayam se kanada loy yawi, B da loy yaw taragadi. In this case, we say A is a subset of B. A se kanagi subset oini harani, B gi subset oraneba. Maramdi kaigino A gi element mayam se B da loy yawreba. B gi element mayam do A da yawbra. A da yawdre ko. A da 1 yawi, 2 yawi, but 3 ga 4 ga di A da yawde. Aduna A gi element di B da loy yawre ko. A is a subset of B tare, but B is not a subset of A. B is the A gi subset oideva. Roman number 2. Set C period elements are 3, 2, 1. Then set D elements are 1, 2, 3. Element animak se chapmanabanina we write kay ibay C is a subset of D and also D is a subset of C. Maramdi kay gino C gi element naam se D da loy yawi, D gi element naam se C da loy yawi. Aduga masing su chapmane. Masing su chapmanabanina sta yariba sign sa equal oibagi signs neba. A is a subset of B, number of A may be equal to number of B. Number of A ga number of B ga manabya bagi sans leba. See the C ga D ga se. C gi element naam se D da yawe. All the elements of D are in elements of C. Then we can write C is a subset of D and the C is a subset of D is a subset of C since elements of C and the elements of D are equal. C ga D ga se chap manaba set way. Trying to write subset ki definition khangeko. Then let's define proper subset. A set A is said to be a proper subset of set B if condition A is a subset of B but number of A should be less than kaidagi hantagadaba number of B dagi. Ngasagi subset ki case tana ani se manaba yabagi case laineba. Aduga proper subset harakpa kandadadi ani se manaba yaroibako. N is denoted by kaina denote tawni. And it is denoted by a proper subset of B. So interrogal A se B gi proper subset ni have sumain denote tawrani ngasai case tana sida equal to yawbagi chance legani handakti equal to yawba yararoi kaigino number of elements of set A is always less than number of elements of set B. Number of A ga number of B ga se number of B na always hengradamneba. Then example A laireko magi elements A B C B consists of A B C D E smayare adidi A ga B ga check tawrasi. A ga B ga check tawbakanda all the elements of set A are in set B and the B is the bigger set. Number of A is less than number of set B. In this case, we write A is a proper subset of B. A is a proper subset B or A is a subset of B. Subset hariso dumyari kaigino habakanda koina A ga B ga say A gi elements se B da loin yare ba se ko aduga kanana chawbadi hele B na chawbadi hele. See case but we cannot write A is a subset of A. A se A masagi subset ne ibade maramdi kaigino A is a subset of A haina ibadi A is not a proper subset of A. Mana proper oi haba yadabagi maramdi number of A habasiga number of A habasiga chapmaneba. Number of A ga chapmanadoini habadi chapmanaba set nidana number of elements in set A will be equal to number of elements in set A. But from the definition of proper subset, number of set A should be less than kanadagi hantagadabana number of B dagi hantagadabane aduna koina khangi se A ga B ga harappa kandadi A se B gi proper subset ne harasu yare A is a subset of B harasu yare but we cannot write A is a proper subset of A. Sapmanaba set amada nangse masana masagi kai taba yade masana masagi proper subset oiba yade kai oibadi yai. A is a subset of A haina iba yai. B is a subset of B haiba yai. C is a subset of C haiba yai maramdi kaigino in case of subset haibasidadi C gi set siga C gi set siga chapmanaba yabagi case lay aduga proper subset harakpa kandadi nangi right ta lairisina left ta gi always yamdrabada element ama hengadabane duna sida notes laireko. Notes number 1 every set empty set phi is a subset of every set. Nangonda set ama piragadi phi sina adum kai tarani subset oineba. Phi means a set having no element ko. So we assume that phi is a subset of every set. Nangonda set leradi magi subset always lerani karamba set no empty set. Roman number 2, there are always two subsets for a non-empty set A, that is phi and itself. Nangonda non-empty set oiba set piraba. Adugi magi adum sungsoi soidana subset ani phangneba. Karamba subset no haradi phi haibaduga masaduga dum oidine ko. Number 3, for any non-empty set A, we write A is a subset of A. Nangonda non-empty oiba set piraba. Dudi kamaina ibyare A sa A masagi subset ne haibayani, but A is not a proper subset of A. A is a subset of A means number of A may be equal to number of A. But in case of proper subset, number of A cannot be equal to number of A. Ani manabaya study manabaya vanina sigi symbol se use to be study sigi symbol se use to be ade. Asigi ona de sta loiselase.